This is the really cool section. We combine all of chapter 4 with our good pal from chapter 3. And I won't tell you which pal from chapter 3. You are just going to have to find the pal. See when the pal pops up. So what is logarithmic differentiation? All right. I'm going to abbreviate here. There's a couple steps. And we'll say why these steps are important later. But the first step, I don't know why the first step is red, but it's red. We're committing, okay? We're going to take the natural log of both sides. And then we're going to ddx both sides. And then we're going to solve for y prime. So for those of you who really like step-by-step stuff, here it is. For the rest of you, let's get going. Example 1. Find y prime. Part A. Y equals the xth root of x. So, why do we have to use this fancy method? Why are we introducing a new method? And the answer is because we have no other choice. Sometimes it'll make logarithmic differentiation make things easier, and sometimes we really just don't have a choice. Because remember how radicals work. The index of a radical is the denominator of an exponent. And I can take, this is not easy to differentiate. We can't use the power rule on this because the exponent's not a number. So it's a really, really bizarre kind of function. And we have to use logarithmic differentiation. So what does that say? Step 1, take the natural log of both sides. So let's do that. ln both sides. We get the natural log of y equals the natural log of x to the 1 over x. And there's sort of a little step 1.5. Step 1.5 is simplify. That right-hand side simplifies. We have the natural log of y equals the exponent can come out in front. We couldn't take the derivative of this because of that exponent. But if we take the natural log, exponent is gone. We're going to get 1 over x times the natural log of x. And this is much nicer to differentiate. We are ready for step 2. All right. So step 2 says ddx both sides. So what's that going to look like? We're going to have the derivative with respect to x of the left-hand side, which is the natural log of y, equals the derivative with respect to x of the right-hand side, which we can write as, it was 1 over x, but we can write that as x to the negative first power, times the natural log of x. Wait a minute, Jason. This is 3.3. This is implicit differentiation. Or is that 3.2? This is chapter 3, implicit differentiation. Okay, so we take the derivative of both sides with respect to x. So the left-hand side, the derivative of the natural log is the reciprocal of the inside, 1 over the inside. But we have to use the chain rule. That's what implicit differentiation is all about. We can take the derivative of y with respect to x pretty normally. But we have to multiply by y prime at the end, or dy dx, because y is dependent on x. Right-hand side, we're going to have to use the product rule. Derivative of the first thing is the power rule, times the second thing, plus the first thing times the derivative of the second thing. Derivative of natural log is the reciprocal of the inside. This was step 2, by the way. And again, there's a step 2.5 to simplify. Let's just simplify all the time, okay? Simplify all the time. We're going to get 1 over y times dy dx equals, what does this become? Negative natural log of x over x squared. Remember that's a negative exponent, just means it's in the denominator. The other one is 1 over x times 1 over x. That's 1 over x squared. Now we say, okay, we did step 2.5, simplify. Step 3, solve for y prime. So to get dy dx by itself, we have to multiply both sides by y. We multiply the left by y. We multiply the right by y. We'll get dy dx equals this whole thing times y. I'm going to write the y in the front. And we usually like writing the positive things first. Okay? And in fact, while we're at it, right, they both have an x squared in the denominator. Let's just factor out that x squared. Of y over x squared, goodness, I wrote it too small. Y over x squared, what's left over is 1 minus the natural log of x. So a couple steps here happening. We're factoring out the x squared. And we're switching the order. We're almost done, but we're not quite. I don't want your answer to have y in it for this. Sometimes we have to have our answer with y in it because we don't know what y is. But here we definitely know what y is. Y is the xth root of x. So let's replace. Oh, this was step 3, I suppose. Now step 3.5, simplify. Just simplify all the time. We're going to get that y prime. And again, you can write dy dx or y prime is equal to y, which is the xth root of x, over x squared times 1 minus the natural log of x. And again, there's a couple of other ways of writing this, but this is a good looking final answer. Wacky though. A wacky problem. Who would have guessed that this is the derivative? Not me. But it's true. Implicit differentiation for the win. Again, this works because y is equal to the xth root of x. All right, let's do one more problem. So sometimes, like in part A, we have to use it. There's no other way of finding the derivative other than this method called logarithmic differentiation. Sometimes it just makes things easier. This one's a real cheeky example I made up just for you guys earlier today. X plus 1 squared times x plus 2 cubed times x plus 3 to the 4th times x plus 4 to the 5th. We do not want to take the derivative of this problem the normal way. We'd have to use the product rule 3 times. We'd have to use the chain rule a bunch. It will not be a good day if we took the derivative of this function the normal way. You want to try it? Go ahead, be my guest. Let me know when you finish in 5 years. Okay? We're going to use logarithmic differentiation. It'll make things easier. Take the natural log of both sides. That's our step 1. So the natural log of y equals the natural log of all this stuff. And I'm getting upset with myself for making this example because I really just don't want to write it down. I want to skip steps. But I'm going to be a good mathematician and not skip all the steps. Now the right-hand side, we are going to simplify. And this is where I'm going to skip steps. So I'm not that great of a mathematician, okay? You've only got like a, no teacher is perfect. Let's simplify. Step 1.5. If you do a couple simplifying steps, just like in the first video, this becomes 2 times the natural log of x plus 1, plus 3 times the natural log of x plus 2, plus 4 times the natural log of x plus 3, plus 5 times the natural log of x plus 4. Okay? And now we have to take the derivative. Step 1, natural log both sides. Step 2, take the derivative of both sides. Right? We're ddxing the left-hand side and the right-hand side. I don't know where I'm going to write it. All right? So the left-hand side is always going to be the same for logarithmic differentiation. Derivative of natural log is 1 over the inside times y prime. Derivative of the right-hand side is not too bad. It's going to be 2 divided by x plus 1, because derivative of natural log is reciprocal. Plus 3 over x plus 2, plus 4 over x plus 3, plus 5 over x plus 4. Look at that. Just like that. That derivative of that right-hand side is so much easier than the derivative of the right-hand side up here. Logarithmic differentiation, flexing its muscles for you guys. It was just like that. That's the power of this. So much quicker to take the derivative than it was before. We can really take the derivative of some real nasty stuff now. But now we have to multiply both sides by y. That's our step 3. So we get y prime equals y times all this stuff. And again, what is y? Y is really ugly. So this all right, this is where it's not perfect. It's not perfect, okay? So it's going to be y times all of this stuff. And we have to write down what y is. So at the very end of the day, we're going to get y prime is equal to y, which you'll remember was x plus 1 squared times x plus 2 cubed times x plus 3 to the 4th times x plus 4 to the 5th. That's just our y times this stuff. 2 over x plus 1 plus 3 over x plus 2 plus 4 over x plus 3 plus 5 over x plus 4. And we're going to leave it just like this. All right, and that's going to be our final answer. And again, as a reminder, this thing right here is y. Whew. So it's not a pretty answer, but it is way, 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 way prettier than it would have otherwise been. Okay? And again, there are ways of simplifying this a little bit more, but I'm not going to ask you to do it. This is as simplified as I need you to make it, right? But it's a little bit more that we can do, but we'll end here. There's some cool things with logarithmic differentiation. I love this section. I think it's awesome. I think it's really powerful because I promise you, I wish I just had 2 hours with you. Maybe I'll just make a 2-hour video of me doing this derivative the other way. It would take forever. Not actually 2 hours, but maybe like a good 15 minutes, 20 minutes of me going quickly. But this is so much quicker with logarithmic differentiation. Follow these steps, and you too can have the power of this overpowered math technique. If this technique were a video game, it would get nerfed. All right. Anyway, bye-bye.